So we give the floor now to Kevin Tittel, who will present some results from the Oncovalue project on using real-world data.
Let's see if it works. Great. So good afternoon, everyone. My name is Kevin Tittel, and on behalf of my research group at the Netherlands Cancer Institute, I would like to present our current work on using real-world data for health technology assessments based on the real world within Oncovalue. So Oncovalue is a European Horizon project that started last year and runs for 4 years with the objective to further unlock the full potential of real-world hospital data for efficient use in HTAs, health technology assessments, by guiding and enabling cancer hospitals to collect and harmonize and analyze this data. It's a big project. 6 clinical centers from 5 different European countries are involved, as you can see in the picture. The project is led by HUS, and a bunch of technical partners are involved, all focused on hospital data, such as in the following graph, where in particular we're focusing on structured data, which is on the left-hand side, such as procedures, drug orders, costs, quality of life, and towards unstructured data and everything that's in between, data that we can find in notes and reports or even imaging. And there are some questions. Is this data even available? Is it being collected in our centers? There are more. Is it structured? To what extent is it structured and already usable? Is the quality sufficient and good enough for an analysis? And if we compare across centers or databases, is it comparable? Is the data standardized and comparable? Is it interoperable, and can we easily link this data to outside sources? And you might think those are a lot of questions, but they're relevant, as we believe that these hospital systems house rich amounts of information, such as the following variables in this word cloud: a lot of contextual factors, patient background information, reasoning for discontinuation, dose reduction, clinical decision-making, you name it. And by collecting this data, we aim to detect patients that generalize to the normal population with results from clinical practice and hopefully, maybe, possibly a longer follow-up period, but allowing us to answer very relevant questions that are taking place in the hospital right now, such as the following illustrative example. Imagine that we're looking at the breast cancer patient setting, and we want to know, is a newly implemented immunotherapy cost-effective? So we aim to compare the immunotherapy in conjunction with the chemotherapy to a chemotherapy-only setting, and to conduct this full HTA, we need the following 3 data blocks on the right-hand side, which are effects, quality of life, and costs, besides adverse events, for example. And this becomes even more interesting and relevant when knowing that some of these new medicines are only implemented in some countries and not in the others yet. So we can exploit this hospital data and do something with that. And that's exactly what we're working on within the Oncovalue. There's some output to be expected after these 4 years, such as AI tools. IQVIA is working on this NLP tool to structure free text data, and Siemens is working on a deep learning-based tool to quantify tumor growth. BC Platforms is creating this infrastructure to enable federated analysis, such that we don't have to share data anymore and we can run meta-analysis across centers, as well as mapping this data to the OMOP common data model, commonly being used for research these days. And last but not least, this HTA framework that we are working on for the work package 2 with the NKI. An HTA framework that is based on real-world hospital data. Which brings me to the three main questions of today. To what extent is the hospital data already well integrated and already usable for an analysis? What is the current status? Then what challenges and issues do arise when working with real-world hospital data? And subsequently, which improvements do we need to advance the use of this data? That's why we've set up a first study, which is the Oncovalue feasibility study. And the objective of this study is to investigate the quality and the suitability of the currently present real-world hospital data in our centers. We have selected a setting of early breast cancer patients receiving neoadjuvant therapy between 2015 and 2023. So as you see in this graph, is a two-phase study. We are now conducting a retrospective cohort study to extract effects, quality of life, and cost data in each of these centers participating, but separately. We're not doing any data sharing for now. And alongside this extraction, we are conducting semi-structured interviews to assess the equality and suitability of the data. So, to delve a little bit more into the data of interest, it's a lot. On the left-hand side, you see the data block of baseline characteristics. It's a lot of demographics, confounders, treatment effect modifiers. The middle box shows you all the information on systemic therapy, surgery, radiotherapy, and the right-hand side, it's all about the outcomes and endpoints, adverse events, but very importantly, quality of life and costs. And alongside extraction of this data, which is, by the way, happening in the following 6 centers participating in Oncovalue, we are already conducting our first interviews with a questionnaire that has been structured according to the ISPOR framework on EHR data suitability, which has a draft version has been released last year. And there are 2 main components in this framework. The left-hand side of data characterization is very technical. It's all about the data architecture, the data pipeline, how does the data flow through the system, what is the origin, how is it integrated, who touches it, who is responsible for validation, quality assurance. It's a lot, but we will delve into it when presenting the preliminary results. And on the right-hand side, it's about fitness for purpose. Is the data that we have fit for purpose, reliable, and relevant for the question that we want to answer? So now I would like to present some preliminary results, starting off with the technical part. So what we see is that the Oncovalue centers already differ considerably in terms of architecture and maturity. This picture is just a high-level example, but contains many components that are commonly present in each center. And what we see is that most centers are currently employing a data warehouse or even multiple within the center, repositories, and all these warehouses and repositories contain structured data, or rather structured data that is being modeled according to a certain logic, and that is coming from all the different source systems, such as the EHR, surgery system, pathology system, etc. Some centers are already building or planning to build a lakehouse. This is even wider and bigger, where all the structured and unstructured data is within one platform or server. And usually the data here has improved quality measures, and data linkage is more easily possible because all the data is already in the same server. And then some centers are building an OMOP database or implementing their federated infrastructure currently. And why is this important? Well, the heterogeneity and the differences in terms of architecture and maturity of these systems, we believe that those affect the availability and quality and fitness for purpose of the data. So when moving on to data availability, we see that this varies considerably over time from 2015 to 2023, but also patient groups and data domains. What do I mean by that? This heat map already presents or gives an indication of the availability for a selection of data blocks over this lengthy time period. And what we see is that even though the majority of these data blocks are generally available and collected, There is a lack of data for earlier years, and especially for patients that come from other centers or move to other centers during their clinical pathway within the center of interest. Also, for some data blocks, such as the adverse events, only proxies are available, or there is partial collection only for the severe ones. And some data blocks aren't even collected. Quality of life is not collected in multiple centers, as well as real-world costs. But there is hope. Some centers are reforming their current data collection already. We see that centers are interested in having these structured adverse events forms or quality of life questionnaires that have been implemented for a couple of years now or are supposed to be implemented soon. So for the available data, let's have a look at the structure. This heat map shows you for 3 centers and for a selection of variables, the data structure. And what we see is there's a lot of heterogeneity, once again. For some centers, it's rather structured. For others, it's rather unstructured. And even for one variable, this can differ. Often because multiple sources are needed to derive the information of one variable, such as EHR fields that are structured, unstructured nodes. And for the unstructured data, we see that the information put in by clinicians is rather heterogeneous as well, which complicate the data processing when we need to have a comprehensive data set that contains all the information, often processed by data managers and researchers themselves, doing the manual processing using complex logic and interpretation. However, as this is developed now within Oncovalue, we are working on the NLP tools as well that seek to derive the data from the heterogeneous clinician reports and notes. And this is a challenge, often because these have to be validated and trained the other way around on language-specific data or even hospital-specific. Now we want to have a look at the quality of the data. But first, we need to understand what are the processing steps and quality checks in place, such as the following on the screen. We see that from data collection and entry by clinicians, administrative staff, even patients themselves regarding the quality of life, all the way from that to data analysis by us researchers, there are many processing steps that manipulate this data. So when looking at a path from the EHR to a warehouse or a lakehouse, there are a lot of processing and integration steps in place. And even further on towards an OMOP database, there are extensive OMOP ETL processes that extract, transform, and load this data. So all centers do, to some extent, still manually process this, as mentioned specifically for variables in need of interpretation, such as a TNM status. But the majority of data is already being modeled and processed automatically, using packages, using ETL processes, and similar tools, as well as AI tools, such as CTQ, in use in our Oncovalue project that is in place to process as well as retrieve data. And we come to a similar conclusion that these implemented processing steps affect the availability, quality, and fitness for purpose of the data of interest. So alongside this processing, there's a lot of quality checks going on. Once again, from data entry to data analysis, all these centers implement varying quality assurance procedures, such as the ones presented on this slide. Starting at data entry already, which is very crucial, as garbage in, garbage out, right? So we need to make sure that the data that we enter is being checked in some ways, and this is happening in the centers. For example, when clinicians enter their data, there are a lot of invalid data warnings, or if their forms are not complete, there are incomplete entry warnings. Clinicians are being trained when using an EHR system for the first time. There's blinded review being done, as well as regular quality reporting, happening often twice a year. Then alongside this data integration and ETL processes, there are extensive quality checks, quality dashboards monitoring this mapping. And even within one platform, such as this data lake or data lake house, there are varying levels with different degrees of quality. So the quality, given these processing steps and quality checks, this heat map shows you and gives an indication of the data completeness, or the amount of missing data for a selection of variables, once again over the time period of 2015 to 2023. And what we see is the data completeness really differs. It's per data domain, but also the structure of the data source, which is quite trivial. However, as we see that for some variables like diagnosis, medications, but also death, this is well documented and complete for all centers. But for breast cancer specific data, such as the ER, PR status, tumor grade, and histology, this differs even if we look at preoperative and postoperative, which shows you that for either one of the two, clinicians don't always put it into their forms or notes. This is just one domain, right? We are still looking further into other domains such as conformance, plausibility, persistence, and accuracy, which brings us to the question, what is a golden standard? What is the ground truth? Do we trust our EHR, or do we trust our warehouse? What do we trust? Which quality, which data source or system? Given that we report on quality, we can choose to do something in terms of methods that can account for biases and uncertainties, which is why we believe that quality reporting is so important. It's the next step. Data quality reporting is paramount to generating trustworthy evidence for HTA purposes. HTA bodies will likely only trust our data if we show them how good the data is. In terms of comparability, we are approaching the end of this presentation. A lot of mapping is happening inside our centers. Mapping to OMOP. I'm not sure if you are familiar with it, but this graph tries to convey the message. The data that differs considerably across centers in terms of definitions, formatting, you name it. We would like to standardize that data and make it comparable across centers such that we can more easily, efficiently, and reliably conduct analysis. And this can, for example, be done by OMOP mapping. And this mapping has already started in 4 centers out of 6. But it's very complex. Experts need to be involved that have a lot of knowledge. It's a long process. However, we believe that within Oncovalue, it's important. It's important for reliable and efficient multi-center studies based on real-world data. Which brings me to the last point. Given that the data is mapped to OMOP, we could aim for federated analysis. Which means that instead of sharing data across centers, we don't have to do that anymore. Data can stay within each center. And we can perform meta-analysis by running scripts, such as HTA scripts, within the firewall of the center on the patient level, row level data. This infrastructure coming from BC platforms, in our case, is already tested and implemented in the first center. And as mentioned, it's without sharing to preserve patient privacy. And centers only share aggregate results to a meta-analysis server. But this is also relevant, and we see this as a part of the future-proof HTA framework that we are creating within Oncovalue. Discussion and conclusion. We had a lot of questions, a lot of issues, or relevant questions at least. But we believe that almost fits inside this yellow box, but the transparent data documentation is needed to understand the quality and suitability of our data for HTAs, driven by the following 3 factors: the hospital system architecture and maturity, and the level, the extent to which this is well advanced, the use of AI tools for processing and extraction, and standardizing and mapping of the data to a common data model, such as OMOP. And we will continue to find out and explore the current status of all those things that I mentioned in our centers, and come back to you soon. Thank you for listening.
Okay, thank you very much. I suggest that we continue with the next presentation and then go to some questions. But